This video covers building block 2 for Unit 12 over solutions. Building block 2 covers solutions and factors affecting solubility. So we're going to talk about what a solution is, how they're made, and then we're going to talk about solubility and how solubility can be changed and or sped up or slowed down. So building block 2's learning goals are to be able to describe the process of dissolution and also to be able to list and explain methods to increase or decrease the rate of dissolving a gas, solid, or liquid in solution. All right, solutions and solubility. So a solution is a liquid mixture where we've got one substance, we're going to call that the solute, that has been dissolved into another substance, and we're going to call that the solvent. And it's the resulting mixture is uniformly distributed. So it's like a homogeneous mixture. It's a homogeneous liquid mixture. There are two parts to a solution. Like we said, we have the solute, and this is the substance that is inside or being held by the liquid. And the solvent, this is the liquid substance that is usually in greater quantity and is the substance that's holding on to the other, or holding on to the solute. So if you take a look over here at these pictures, in this first picture I just have pure water. And pure water is usually our solvent because it can dissolve lots of different things. Over here we've got a solution, and you can see we've got the water and it's got some things dissolved in it now. So it's holding that solute. These purple particles represent the solute that's dissolved into the water. Solubility is how easily something can dissolve into another thing. Some things that dissolve easily, for example, salt dissolving into water, are said to have high solubility because it's very easy for them to dissolve and get mixed in with that water. Some things have more difficult time being dissolved, so like oil and water, we don't really typically think of these things as mixing, but if you can get them to mix, you can get them to mix temporarily sometimes, but they always end up separating back out. We can say that things like this have low solubility, and then there are other things like sand. There are other substances that just will not dissolve in water at all, and we say that those are not soluble. So how are solutions formed? They're formed through a process called dissolution. And this is the dissolving of one substance into another to form a solution. So the overall process is called dissolution. And dissolution occurs through a smaller process called solvation. And this is the act of molecules of a solvent interacting with the molecules or particles of a solute to form a solution. So we've seen this picture, we saw it again, or we saw it previously on another slide, but this is a good picture to describe what's going on here. Here is our solute right here, and our solvent is the water molecules. And you'll notice water molecules are coming over here and starting to surround this particle right here. Solvation is this little microscopic process that's going on right here. So solvation is the tiny process that's going on where each little particle is surrounded by water molecules and moved away from the main body of the solute. And then the whole process going on, on a large scale is dissolution. You don't really have to remember the term solvation. I'm not going to test you on that. It's just an explanation of what's really going on. But you do need to know what dissolution is, and it's just the dissolving of one substance into another. And if you want some more help with dissolution, there's a video, the Help at Home video in the PowerPoint that is also posted along with this video. Okay, so now we need to talk about some factors affecting solubility. Some factors that that affect either the rate at which something can dissolve or whether something can dissolve at all, the ability for it to dissolve, are temperature, agitation, particle size, pressure, and polarity. And we're going to go through and talk about each one of these individually. All right, so temperature and solubility. Temperature affects solubility depending on what your solute is. So if your solute is a solid, such as sugar or salt that you're trying to dissolve in water, then increasing the temperature is going to increase the rate at which those dissolve, and it's actually also going to increase the capacity for the solvent. The solvent has to hold a certain amount of that solute. So higher temperature water can hold more sugar than water at a lower temperature, and it can also dissolve that sugar faster. If we decrease the temperature of a solution or of a liquid, it's going to slow the rate at which that solute is dissolved. And the reason why we see this pattern is that when we have a solution that's warmer, the solvent particles are moving past the solute at a greater rate, and there's more kinetic energy in there, so everything's moving around a lot faster and it can dissolve faster. If we cool it down, the particles start to slow down, things are moving slowly, so the overall process of something dissolving is going to be more slow. If our solute is a gas, though, if we increase the temperature, this is going to slow and decrease the amount of gas that can be dissolved in that liquid. And if we think about what's going on here, it's the opposite of what we saw with the solid solute, because gas particles already contain a lot of energy. If something is naturally a gas at room temperature, it's already got a lot of energy. And the faster the particles that it's dissolved in are moving, the faster it's going to be able to wiggle its way up to the top and escape from that solution. So not only does it have more energy at a higher temperature and it's more easily able to escape that way, but all the other particles that are kind of holding it in solution are moving faster and allowing it to move by faster, allowing it to escape. So that's why when we drink soda, it's better to keep it cold so that the carbonation stays in longer. If we decrease the temperature of a solution, it's going to slow the particles in the solvent, and it's also going to decrease the movement of gas particles. The slower motion allows gas particles to stay dissolved in the solution longer, and it also allows for us to be able to dissolve a little bit more gas in that solution. It can hold a little more. Right. Agitation and solubility. Agitation is the act of moving something back and forth, and in this case, we can think of agitation to mean shaking, stirring, swirling, mixing, anything you can do to get particles moving around faster without heating them. For solid solute, such as salt or sugar dissolving in water, agitation is going to increase the rate of dissolution. So it's going to increase how quickly or the speed at which something's dissolving. This is because the solvent particles, again, in this case, they're moving faster. And this time it's not because we're heating, it's just because we're physically moving the particles by stirring or swirling. And so that's going to cause something to dissolve a little bit quicker. Although agitation will cause a solute to dissolve more quickly, it does not increase the solution's capacity to hold more solute. So unlike increasing temperature, when we increase temperature, that solution can hold more solute. Agitating does not make more stuff dissolve. So the only thing that agitating can do is just help it to dissolve faster. For a gaseous solute, agitation is also going to decrease the amount of gas that can be dissolved. This is because particles of solvent are forced to move about quickly, allowing more gas particles to escape. So if you shake a bottle of soda before you open it, more gas comes out. It explodes all over the place. Particle size and solubility. For solid solutes such as sugar dissolving in water, Large particles are going to dissolve more slowly than smaller particles. And the reason for this is because large particles have less surface area than many tiny particles. So if you take a look at these squares that I have down here, I've got a big square right here. And if I take that same square, I look and see just kind of relative, the red outline kind of shows you how much surface area, kind of gives you a better visual. So I have this big chunk of sugar right here, and I'm trying to get that to dissolve. The solute can only come in contact with the red part, the red outline part. If I were to take that same amount of sugar and break it into a lot smaller pieces, there's now a lot more red in this picture. You can see that there's more surface area for the solvent to come in contact with. And if I were to even take these squares and break them down a little bit smaller, you can see that the surface area is very, very large. And since the solvent can come into contact with a larger surface area, when we break that into teeny tiny pieces, it's going to dissolve a lot faster. For a gaseous solute, such as carbon dioxide, particle size really has no noticeable effect on gas solubility. All right, so pressure and solubility. Well, for solid solutes, again, like salt or sugar that we're trying to dissolve in water, increasing the pressure or the pressure of the gas above that liquid has no effect on how quickly something can dissolve if it's a solid. However, if it's a gas, then it does have a very large effect on the amount of gas that can be dissolved and that can stay dissolved in that solution. So if you take a look at this picture over here, there's 3 different canisters. The first canister, it's at an equilibrium right here. We've got some gas outside the liquid, some gas dissolved in the liquid. If we push this plunger down and we increase the pressure inside this container, you'll start to notice that eventually, once this system comes to a new equilibrium, we'll have more of those gas particles dissolved in that liquid. And so the greater the pressure, the more gas that can be dissolved in that liquid. So higher pressure equals more dissolved gas. Lower pressure equals fewer dissolved gas particles. And again, pressure doesn't have any effect on solid solutes like salt or sugar. All right, the last thing that we're going to talk about is polarity and solubility. We kind of touched on this a little bit on that first slide when we talked about solubility, but we're going to go ahead and talk about it again. Remember, the polarity of a substance is going to determine what kinds of solvents it can be dissolved in. Polar substances are those like water that have slight charges on different ends of the molecule. And it's these charges that allow the opposite ends of molecules to surround one another. Polar substances can only dissolve other polar substances. Some examples of this, of things that can be dissolved in polar substances, are ionic compounds, and that's because these dissociate in water to form positively and negatively charged particles, and covalent substances that have polar regions with partial charges, so sugars. And acids also fall into this. Acids are typically classified as covalent substances. However, they have hydrogens that dissociate when they are dissolved in water or added to water. And they form positively charged hydrogen ions. And depending on what type of acid it is, if it's hydrochloric acid, you'll have negatively charged chlorine ions. So although they're covalent, they still dissociate in water. So that's why those are listed there. We'll talk more about acids in the next unit. Nonpolar substances do not have charges associated with them. So nonpolar substances, they only dissolve other nonpolar substances. Examples of substances that can be dissolved in other nonpolar substances are covalent substances whose molecules are not polar. A good way to remember this is just that like dissolves like. Polar dissolves polar, nonpolar dissolves nonpolar. And then if you take a look at this table over here, you'll see it gives you just some examples. Polar substances in a polar substance, yes, it's going to dissolve. A polar substance in a nonpolar substance, no, it's not going to dissolve. So there's some examples for you to take a look at. And here's our last help at home video for this these 2 building blocks. This just goes over the factors that affect solubility. Again, if you want to have a quick recap on just one part of this lecture. You're welcome to watch any of those. If you have any questions, you can email me. Also, my office hours for It's Learning for the duration of our online learning time are going to be Tuesday and Thursday from 10 a.m. to 12 p.m. So if you want some immediate feedback, you're welcome to jump on It's Learning and message me through there. If you email me, I will get back to you within 24 hours. Thank you very much. See you guys later.